is we're going to be talking about the other variables, k and h. To start, we're going to talk about k. If k is a number greater than 0, our parabola is going to move upwards. If k is a number less than 0, our parabola is going to move downwards. And we're going to go through some examples of that. So, for instance, our first one, we're going to do y is equal to x squared. And we'll give ourselves a value of k positive, let's do 3. I like 3. Okay. So the easiest way to do this is to start at our vertex. And we know our vertex is 0. I move that vertex up 3 spots. 1, 2, 3. So our first coordinate is now going to be on the 3. Okay? From there, I draw the parabola the exact same way I would normally draw if it was on the vertex. Over 1, and how many do I go up? 1. Up 1. Left 1, up 1. If I go over 2, I would go up how many? 4. 1, 2, 3, 4. And same with the other way. Now, a way to verify this, if we've gone up from the vertex 3, my next coordinate of 1 and 1, I should move up 3. And if you guys notice, this went up 1, 2, 3. This spot went up 1, 2, 3. This spot went up 1, 2, 3. And vice versa on the other side. 1, 2, 3. And this one went 1, 2, 3. Every point moved up 3. So when I go to draw this now, the shape is the exact same. It's just been translated 3 units upwards. Okay. If you guys notice, the next one I put up now is k is the value of -5. The idea is the exact same. I have my vertex, and it starts at 0. I go down 5. So that's going to put me at -5. Over 1, up 1 from that vertex. We always do this rule from the vertex. From the vertex again, I go over 2, up 1, 2, 3, 4. Over 2, up 1, 2, 3, 4. Okay? And with that being said, if we take a look at it, our vertex has gone down 1, 2, 3, 4, 5. This point went down 1, 2, 3, 4, 5. And this point went down 1, 2, 3, 4, 5. Vice versa on the other, 1, 2, 3, 4, 5, and 1, 2, 3, 4, 5. Okay? All these points have gone down 5 spots. So when we go to graph it once again, our shape of our parabola, like we said before, is the exact same. All that's happened is this is translated or shifted down 5 units. Okay, so now we're about to prove it using our numbers. So like we started before, I'm going to just start with the number 0. Okay? So when x is at 0, I plug 0 in for x squared. What's 0 squared? Plus 3. 3. Okay? So here's one of our coordinates, 0 and 3. If we look up 0 and 3, there it is. That's the coordinate we're talking about. Another coordinate we have, let's try when x is 1. When x is 1, I plug it in here. What is 1 squared? Plus 3? 4. 1 and 4. So we go over and take a look. 1 and 4. There's another point along our parabola. Opposite, let's try -1. If I plug in -1 for x, we get positive 1. -1 times -1, positive 1. Plus 3, 4. There we go. Let's take a look at our coordinate. -1 and 4. Yep. And let's try 2 and -2. We know the y's are going to be the same. If I put the value of 2 in for x, 2 squared is 4 plus 3. So both of these are going to be 7. And when we went and looked at our graph, that was right. We had to go 1 spot above the 6. So 2 and -2 at 7. So all those points worked on our graph. So we can mathematically prove that. We're going to do the same over here. When x is 0, what is the y value going to be? -5. If we take a look, we have a coordinate at 0 and -5. That's the vertex. I'm going to quickly fill out the other ones for you. This will be -4. negative 4. This will be 1. All right, negative 1 and negative 1. So if we look at these coordinates, 1 and negative 4, 1 and negative 4, and we had the mirror image of negative 1, negative 4, and our other coordinate was 2 and negative 1, negative 2 and negative 1. All of our coordinates worked when we plugged the numbers in to our equations. Okay, the next one we're going to deal with, and the last one for today, is H. Now, H is a little different from what we're used to. The idea is the same as K, and like I should have specified above, K is a movement along what axis, guys? Movement, move on y-axis, okay? That's important that we put that down. From that, what do we think H is going to be? Yes, move on x-axis, okay? So, now, this could be taught several different ways. Because this is an equation that says x minus h, things kind of get twisted around, okay? If we look at it in the equation, you can always think of it as opposite, but technically the rule is the same. It's that the negative sign is switching what it looks like. So technically, when h is greater than 0, we move, so when h is positive, we move right, or in a positive direction. When h is less than 0, negative, we move left, or in the negative direction. Now, that's going to look a little funny, but I'm going to explain why this rule is. So, when I go to plug in a number for this, y is equal to x minus, I'm going to use the number positive 5, okay? Positive 5. I'm going to plug that in for h, n brackets squared. Okay. So with positive 5, which way should this parabola technically move? To the right, how many units? 5. So I should go 1, 2, 3, 4, 5. There's my vertex. And when I go to draw it, over 1, up 1, over 2, up 4, over 2, up 4. Our parabola, if you've noticed, has shifted 5 units to the right, every point along it. Now, the problem with this is they won't write the equation like this for you guys. The way this equation will be written is y is equal to x. What will end up being here? We have a negative and a positive sign together. Minus 5. So your equation will actually look like that. Now, we did plug in a positive number, positive 5, but your equation is going to look like negative 5. So a way to think of that is think of it as the opposite. If you have your equations like this, x minus 5, we go to the right. We go in a positive direction. Okay? And I'm going to show you vice versa, the opposite equation. I'll do it at the bottom because there's some room here. Y is equal to x minus, we will do negative 3. Okay? So I plug in the number negative 3. Now when I plug in negative 3, which way should I technically go? To the left 3. So 1, 2, 3. There's my new vertex. Over 1, up 1. Over 2, up 4. Over 2, up 4. Draw our parabola. It's the exact same shape. The only difference is it's been moved 3 units to the left. Now once again, the only problem with this is they won't write the equation like that. What will that equation look like? X plus the number 3. So your equation is going to look like the number 3 is positive. So the number 3, if it's positive, think of it like going in the opposite direction. Okay, we're going to prove these numbers now. I'm going to plug in 0 for this equation here. When I plug 0 in, this becomes 0, subtract 5, which gives me negative 5. What is negative 5 squared. Sorry, guys, that doesn't make sense. I just used the wrong numbers there for a second. Okay. Instead of 0, if we go up and look at our parabola here, if you guys notice, this is 0. So this parabola, it's going to be way up here. That does make sense. It'd probably be at 25. I'm going to try to get closer to the x-axis. So I'm actually going to start at when x is 5. Okay? That way we get an idea of where the vertex would be. When x is 5, I plug that value in for x. 5 subtract 5 is what? 0 squared? So one of my coordinates is 5 and 0, and if we take a look, there it is, 5 and 0. Now let's go to the right one. I'm going to use 6. When x is 6, I plug it in here. 6 subtract 5, 1. 1 squared? 1. Another coordinate is 6 and 1, 6 and 1. There we go. Let's go the other way, 4. When I plug the number 4 in for x, 4 subtract 5 is negative 1, and negative 1 squared is 1. Once again, we get the value of 1. So we have 4 and 1, and we can continue that over. So if this is 7, 7 subtract 5 is 2, 2 squared is 4, and let's say this was 3. 3 subtract 5 is negative 2. Negative 2 squared is 4. If we go take a look at those values, we don't have a 7, but if we did, it'd be at 4 and 3 and 4. We have our points along the graph. The entire graph has been shifted to the right 5 units. Let's do the same idea here. I'm going to use the same idea for the vertex. If x is negative 3. Okay. What did I say? All right, negative 3 plus 3. What is negative 3 plus 3 going to be? 0 squared. I'm going to give you the answer. Negative 3 and 0, there's our vertex. Perfect. Let's go one to the left. Negative 4. If I plug negative 4 in for x, negative 4 plus 3 becomes negative 1, and negative 1 squared? 1. Take a look. Negative 4 and 1, there's a coordinate. I'm going to quickly do this. We know negative 2 is going to end up being the exact same. We go over to negative 2. It's going to be 1. Negative 5 and negative 1 will be our next two. That'll be mirror images. So negative 5. If I plug negative 5 in for x, negative 5 plus 3 is, and negative 2 squared? 4. And I know negative 1 is going to have the same one. So let's take a look at those coordinates. Negative 5 and 4. Yep, that makes sense. Negative 1 and 4. Makes sense. Once again, the whole parabola is just shifted to the left 3 units. All of the numbers are the same. They work.